We have to think before we draw. So remember the 3 rules of statistics. Make a picture, make a picture, make a picture. Now that we have options for data displays, we have to think carefully about what type of display to make. We know how to make pie charts, bar graphs, segmented bar graphs, dot plots, stem and leaf plots, and histograms. That gives us 6 different displays that we could make, so we have to make sure we're using the correct one. Before we make a stem and leaf display, a histogram, or a dot plot, we have to check the quantitative data condition, which states that the data values are of a quantitative variable whose units are known. So you want to make sure that you know exactly what the units are so that you know that you're using quantitative data. Once we have the display, we often want to know how the data are distributed. So when we're looking at the distribution, we always want to tell about 3 things: shape, center, and spread. Starting with the shape of the distribution, we want to look, does the histogram have a single central hump or several separated humps? Is the histogram symmetric? And do any unusual features stick out? Starting with the humps. Does the histogram have a single central hump or several separated bumps? The humps of a histogram are called modes. A histogram with one main peak is called unimodal. If there are 2 main peaks, it is bimodal, and if there are 3 peaks, it is multimodal, because statisticians don't count past 2. Just kidding. So a histogram that is bimodal has 2 apparent peaks. So here we can see that there is one mode right here and one mode right here. This gives us 2 distinct peaks, making this histogram bimodal. A histogram that doesn't appear to have any mode means that all the bars are approximately the same height is called uniform. So for example, here we have no actual apparent mode, and most of the bars are roughly the same height, so that would be considered uniform. Moving on to symmetry, a histogram can be symmetric if it's folded in half and can be the same on both sides. It does not have to be exactly the same. We're looking for it to be approximately symmetric, and that will work for us. So with this histogram here, you can see that if you fold it in half, there is some differences. Those differences are okay because we're only looking for it to be approximately symmetric. If it's not symmetric, then it's going to be skewed. So skewed is when one tail stretches out further than the other. It's skewed to the side of the tail. So for example, the blue histogram on the left is going to be skewed to the left because the tail is on the left side, whereas the pink histogram on the right is skewed to the right because the tail is on the right side. Then we're looking for any unusual features. Sometimes it's the unusual features that tell us something interesting or exciting about the data, and a lot of times that can be what we're most interested in. So, for example, an outlier would be something that is unusual. So outliers are stragglers that stand off away from the body of the distribution. So anytime you see an outlier, you want to mention that in the distribution. The other unusual feature are any gaps in the distribution. Gaps tend to indicate that the data may have came from more than one group, so that's often why gaps are going to be interesting. For example, in this histogram here, we have outliers to the left. So I would say that this histogram is unimodal, roughly symmetric, but it does have outliers that we would have to mention. Now, we do see a gap here as well. That gap does not have to be discussed. The fact that you are stating the outliers indicates that there's going to be gaps because an outlier by definition is away from the data itself. You're going to want to mention gaps when the gaps are separating 2 distinct pieces of data. So if it's going to be bimodal and there's a gap in between, that's when you'd want to talk about the gap. Then we're going to talk about the center of the distribution. So the center of the data is going to be a single number to describe the data as a whole. It's easy to find the center if it's unimodal and symmetric because it's going to be right there in the middle. But it's not quite as easy if the histogram is skewed or if there is more than one mode present. There are two ways to describe center. The first is with the median. So the median is the value that is exactly in the middle of the data. Half of the data values are below, half the data values are above. And the median will always have the same units as the data. So here in this histogram, we're looking at the magnitude of earthquakes, and the median value is 7. So then half of the data values in purple are below, and half of the data values in yellow are above. With center, you always have to give a spread. So variation matters. Statistics is all about variation. We expect variation, we want variation. It's why we have statistics. So when we're looking at variation, we're looking to see, are the values of the distribution tightly clustered around the center, or are they more spread out? We always have to report a measure of spread along with a measure of center when describing the distribution. So we're going to start with the interquartile range for spread. Now we've all heard of the range and have had years of practice with that, which is just the maximum value minus the minimum value. The problem with this is that it is subject to extreme values, which can make the range really large, even though the data may not actually be all spread out. Therefore, we use what is called the interquartile range, or the IQR, because it lets us ignore the extreme data values and concentrate just on the middle of the data. In order to find the IQR, we first need to know what our quartiles are. So our quartiles divide the data into 4 equal sections. 1/4 of the data lies below the lower quartile, which is Q1, and 1/4 of the data lies above the upper quartile, Q3. Therefore, Q1 and Q3 border the middle half of the data, so 50% of the data lie between Q1 and Q3. The difference in the quartiles is your IQR. So in order to find or calculate the IQR, it's your Q3 minus Q1. The lower and upper quartiles are the 25th and 75th percentiles. So looking at this histogram below, we have the lower blue part, which represents the bottom 25%, and this upper blue part, which represents the top 25%. The pink part in the middle is our middle 50% and our IQR. So again, the IQR contains the middle 50% of the distribution. We can see down here that the IQR is equal to 1. Note that indicates that our data are not all that spread out, whereas if we were to actually use the range, we would probably be closer to a range of 9, which indicates that our data are very spread out. This leads to the 5-number summary, which reports the median, the quartiles, and our extreme values. So for recent tsunami earthquake magnitudes, the 5-number summary is your maximum, your Q3, your median, your Q1, and your minimum. And these are the values of that histogram on the previous slide. As you can see, Q3 is 7.6, Q1 is 6.6, so when we subtract these, we end up with an IQR of 1. The other measure of center is the mean. So the mean is typically going to be used when we have symmetric data, and it's just the average of the data values. The equation for the mean is just your total of your data values added together divided by how many there are. So n represents how many data values you have. The Greek letter sigma, right here, represents sum, and this right here is how the formula will be given to you on the AP exam, and also how I will give it to you on any test. Here, where we have y with a line over it, we call that y bar. Anytime you have a variable with a line over it, it's representing the mean. and it's just called y bar, or if it were x, it would be called x bar. So again, this formula says that to find the mean, we add up all of the variables of the value and divide by the number of data values, which is n. The mean feels like the center because it's the point where the histogram balances. So here we have the histogram of the earthquakes on a different scale. That's why it looks slightly different. But you can kind of see the little balance down here, where at 7, it seems to be where the histogram is actually balancing. So should we use the mean or the median? We're going to use the mean as a measure of center when the data are unimodal and symmetric. So one mode, and there's rough symmetry, we use the mean. Anytime we have anything else, we're going to use the median. So normally that's going to be when the data are skewed, or if you have outliers, because the median is resistant to outliers. With the mean, we also have to give a measure of spread. That measure of spread is standard deviation. Standard deviation is more powerful than the IQR because it takes into account how far each data value is from the mean. A deviation is the distance that a data value is from the mean. So you just take your data value and subtract the mean from it, and that gives you your deviation. Now this means that you can have both positive and negative deviations because some data values will be above the mean and some data values will be below the mean. Because we can end up with both positive and negative deviations, adding them together would end up giving us 0. So we square all of our deviations and then find an average, kind of the deviations. So first, let's kind of talk about variance. Variance is noted with s squared, and it's found by adding all of the squared deviations together and then almost averaging them. That gives us this equation. So s squared is our variance. We take the sum, sigma, of all of our data values minus our mean, and we square those values, add them all together, and then we divide by n minus 1. Because we're dividing by n minus 1, that's why it's almost averaging them, but not quite. Variance is going to play a bigger role later on, but right now it's not useful to us because it's measured in squared units, and we don't like that. So we're not going to really focus too much on the variance at all right now. What we will focus on, though, is the standard deviation, which is given the variable s. The standard deviation is just the square root of the variance, and because we are taking the square root of it, we're able to keep the same units as our original data. The standard deviation equation is shown in red, and again, this will be given to you on the AP test. I will also give you this. I don't want you to get too freaked out by the equation because I'm never going to ask you to calculate standard deviation by hand. Our calculators do it for us. I will show you how to do that, and we will stick to that. Since statistics is about variation, spread is an important fundamental concept of statistics. Measures of spread help us talk about what we don't know, and statistics are pretty much all about what we don't know. When data values are tightly clustered around the center of the distribution, the IQR and standard deviation will be small. A small measure of spread gives a small standard deviation and IQR. If the data values are all scattered out, so they're all very spread out from each other, the IQR and standard deviation will be large. We're going to continue talking about measures of center and measures of spread in class tomorrow, so I will see you guys then. Thank you.